2025 A-Level Combined Mathematics Paper 2 Part A question number 8. This question has to do with equilibrium and coefficient of friction. The question says, a particle P of weight W is attached to the rim of a uniform circular thin disc of center O, radius A and weight W. The disc rests on a rough horizontal floor against a rough vertical wall. The coefficient of friction between the disc and the floor is equal to mu, and that between the disc and the wall is also equal to mu. So both of these coefficients of friction are equal to mu. It is given that the disc is in limiting equilibrium when OP makes an angle theta which is somewhere between 0 and pi by 2 radians with the horizontal. Given this, it says the forces acting on the disc are marked on the figure. We are asked to then show that cosine of theta is equal to 2 mu times 1 plus mu divided by mu squared plus 1. Now, in order to do this, we can see we have given all of the forces in the diagram. All we are going to have to do here is to apply some equations that we can use in the case that this is in equilibrium, and by doing that, construct some equations that we can rearrange and simplify and substitute in all of that in order to eventually get cosine of theta equals all of this. So, considering the equations we can make, since this entire system of forces here is in equilibrium, we can say due to equilibrium, if we apply F equals ma, we can see all of the a's are going to be equal to 0. So all of the equations we make in either horizontal or vertical direction are going to have equal 0. And if we consider the horizontal direction and vertical direction, we're going to get two equations. Horizontally, all the forces should sum to 0, and the forces that we have are negative r2 and mu r1. So we have negative r2 plus mu r1 equals 0, which we're going to call equation number 1. Or further, we could simplify this to r2 equals mu r1 and then call that equation number 1. Now, in the vertical direction, if we consider the forces that we have downwards 2 w's. We have downward w here and downward w here, and we have upward r1 and upward mu r2. So we can say r1 plus mu r2 minus w equals 0, which we could rearrange to get r1 plus mu r2 equals 2w, which we're going to call equation number 2. Now, with these two already we can do a lot of substitution, but we're going to skip that for a little bit and consider one more equation we can make. So what we've done so far is consider the forces in the horizontal and vertical directions. Additional to this, we can consider moments. Now, we have a lot of points that we can take the moments around. We can take the moments around this point, we can take the moments around this point, and we can take the moments around this point. But if you consider this point, we can see r1, this w and this r2 are all going through the same exact point. The only forces that are not going through that point are mu r1, mu r2 and this force of w which is acting at the point P. Now, considering those three, if we apply the moments around O, taking moments around O, we can see that for this thing we have mu r1 in, let's say, the anticlockwise direction. So we have mu r1 at a distance of a, since the radius of the circle is a, so we have a mu r1. And then additional again in the anticlockwise direction we have mu r2 at a distance of a, so we have plus a mu r2. And additional to this we have w, but w is in the clockwise direction, so it's negative, so we have minus. And considering the distance of w, it is this distance right here, which if you take a look, this hypotenuse is a, and therefore this angle here is going to turn this length here into a cosine theta. So we have a cos theta times w, so we have a w cosine theta, and that's also equal to 0. Now, using this one, we can see we can cancel all the a's, and we're going to get w cosine theta equals mu r1 plus mu r2, which we could rearrange to get that cosine theta is equal to mu r1 plus mu r2 divided by w, and that's going to be equation number 3. Now, with these three, we actually have enough information to fully solve for cosine theta and find that cosine theta is equal to 2 mu times 1 plus mu divided by mu squared plus 1. So, if we start doing this, we can see r2 is equal to mu r1. So, combining 3 and 1, we can see we're going to get cosine theta equal to mu r1 plus mu times r2, which is also mu r1. So, therefore, we're going to get mu r1 plus mu squared r1 divided by w, which you could factorize as mu times mu plus 1 times r1 divided by w. Now we've gotten to this point. Now after this, let's say we call this equation number 4. After this, we can substitute R1 divided by W using equation number 2. Looking at equation number 2, we can see R2 is again mu R1. So from 2 we can get R1 plus mu times R2, which is mu R1. So mu times R1 equal to 2W, which we can see if we simplify, we're going to get 1 plus mu squared times R1 equals 2W, which rearranging we can get that we want R1 over W, so we can get R1 over W, and that's going to be equal to 2 over 1 plus mu squared, which we're going to call equation number 5. Now finally we can see, combine equation number 4 and equation number 5, that cosine of theta is going to be equal to, and if we place R1 divide by W, we can see we're going to get 2 to divide by 1 plus mu squared times mu plus 1 divide by W, which we can write as 2 mu plus 1 divide by 1 plus mu squared, which is going to be our final answer. So that's going to be all for this question. We can see we've exactly gotten our final answer that we wanted in the question. Now finally, if we consider the marks awarded for this question, when you take the forces horizontally using F equals ma and say due to equilibrium it's going to be equal to 0 and get equation number 1 here, you get 5 marks. Similarly, when you take them in the vertical direction, you get equation number 2 here, you get another 5 marks. Additional to this, when you take the moments in either the clockwise or anti-clockwise direction in order to get this equation number 3 here, you get another 5 marks. After this, when you resubstitute and you get this equation right here, R1 over W is equal to 2 over 1 plus mu squared, you get another 5 marks, and you substitute that with this equation here to get the final answer of cosine theta is equal to 2 mu times 1 plus mu divided by mu squared plus 1, you get another 5 marks. And that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.